Welcome to topic number one, define statistics. So the very first topic of this course, I want to go over some definitions that we will be using throughout this semester. So again, welcome to probability and statistics. So let's take a look at some of these words that we'll be using throughout the semester. So let's do some definitions. So the very first word is the word statistics itself. What is statistics? Statistics is the science of collecting, organizing, summarizing, and analyzing information. What do we need to collect, organize, and summarize and analyze? Well, to draw conclusions or answering some questions. Okay, so we propose a question, then we need to collect, organize, summarize, and analyzing these informations in order, okay, to answer the question that we propose. So by going through collecting, organizing, summarizing, analyzing, it provides a measure of confidence in any sort of conclusions that we draw when we answer the questions. Okay. So statistic is a very very vast subject. We actually live in a statistical world without really seeing the numbers, without actually seeing these numbers, but it's all actually around us. Perfect example. In the state of South Carolina, we have to pay car insurance. Well, if you actually live in North Carolina and buy car insurance from North Carolina, the prices are different. Okay, your premiums is different. Your basic premium is a little bit different between South Carolina and North Carolina. And why is that? What caused that? So you see, statistics is all around us. We just don't see them, okay, all the time, but they are there. All right, let's take a look at the word data. What is a data? Data are counts, measurements, or observation gathered about a specific variable in a population in order to study. Okay. So what is a population? Population is a particular group of interest we're trying to study. So here in my diagram here, population is what we're trying to study. It's a group of interest. Sample is simply a subset of the population in which the data are being collected. Okay, it is almost impossible to collect data from the entire population. Okay, because the population can be so large. So instead of collecting data from this large population, we can take bunch small samples. Okay, we can take bunch small samples. Eventually that can make up your entire population. Okay, so that's a common thing throughout this course, is in order to study the population, okay, we're gonna draw bunch small samples. Okay, we're gonna collect data from all those small samples that actually basically cover the entire population. All right, a variable is a measure, is a measurement or a characteristic that can be determined for each member of the population. A variable is usually notated by a capital letter such as X or Y. So here, for example, if I want to flip a coin 2 times, okay, find the probability of heads. So finding the probability, so that means the heads right here will be your variable. Okay, that variable is a measurement or characteristic that can be determined for each member of the population. Since I'm only flipping the coin 2 times, okay, then that means I can get 0 head out of the 2 flip. I can get 1 head and I can get 2 heads. Okay, that's the reason why the counts are 0 head, 1 head, and 2 head. But the heads are my variable. And right here, P stands for probability. So right here on the right side of it is the probability of obtaining each one. All right, a census. Okay, the word census is a study in which the data are obtained from every member of the population. Okay, so when we take a census, when the government take a census every population census every 10 years, okay, that is trying to collect data from everybody in the population. Okay, that's not taking sample. That's actually called census. Census is trying to get data from everybody. All right, please make, I wrote this note right here. What we really want to do is analyzing data of a population. Okay, we propose a question. Okay, we're gonna collect, organize, summarizing, analyzing our data to draw this conclusion. Okay, so what we're trying to do here is, in order to analyzing the data of a population, okay, instead of collecting the data from the entire population, what we can do is take bunch small samples, like I said earlier, of the population. Because sometimes it's almost impossible, okay, to collect data from the population. So what we want to do is take bunch small samples, okay, that basically cover the entire population. All right. So imagine census, census is very hard to obtain the correct data, but it's the best that the government can do in order to see how many people live in the United States. All right, so here, let's try some example. What we want to do is read these choices and identify the data, population, and sample. So the scenario is this. A study was conducted at a local college to analyze the average cumulative GPA of students who graduated last year. So this survey, okay, is conducted at this local college. So that means all the students, okay, that means all the students who graduated last year from this college, okay, or graduated at this college will be your data. Excuse me, will be your population, excuse me. Okay, not all the students who attend the college last year, because the survey is about the average cumulative GPA of students who graduated college. Okay, so all students who graduated college, oops, that will be my population. All right, so what can the data be? The data got to be the cumulative GPA. So C is the data. See, the cumulative GPA of one student who graduated college last year, that cannot be, that's just one thing. Okay, this is one student. So all my data got to be cumulative GPA, such as 3.65, 2.8, 1.5, 3.9. All right. The average cumulative GPA of students who graduated from college last year, okay, that would not be my data. Okay, the cumulative GPA itself, okay, are my data. This average cumulative GPA of students who graduated, so that average simply implies that once I got my data of all the cumulative GPA, okay, we actually come up with an average of that. Okay, so that is actually one numerical value. So the cumulative GPA itself are the data. All right, what are the samples? Randomly selected a group of students who graduated from the college last year. That will be the sample. Who graduated from college last year. Okay, because I'm looking for the people who I'm trying to look for the GPA of the student who graduated last year. So this got to be the sample. All right. So again, the average cumulative GPA of student in the study who graduated from college last year. So that is actually referring to all the students. Okay, so when we take samples, we want to randomly select a group of students who are going to graduate college. So some of these choices are very, very close, but you got to pay a little bit more attention. I know we're trying to, I know this average cumulative GPA can throw students off. Okay, but the sample are within the population. All right, let's take a look at a couple more definitions. All right, types of statistical numbers. Okay, there are two types of statistical numbers. First is called a simple statistics. Okay, simple statistic are numerical description of a simple characteristic. Okay, it's a numerical description of a simple. A perimeter is a numerical description for a population. Okay, so perimeter associated with population. Simple statistic is a numerical value for the simple. A perfect example, what are some of the numerical description for simples? We can have simple mean. Okay, perimeter can be population mean. Okay, those are different. This will be one of the main, this is one of the main two numerical description. We will be talking about three of this course, population and simple means. All right, so here's a table kind of help you separate between, help you distinguish between population and simple. So you can read up on that. All right, let's take a look at numerical value described by population, perimeter, or a simple statistic. Okay, so this is a little bit tricky. A recent poll of 1266 corporate executives showed that the average price of a corporate executive car is 45,000. So the 1266, okay, are my simple. So the average car price of that simple got to be the simple statistic. Okay, so the number I'm actually trying to, so my numerical description is the 45,900, but this number come from a poll of 1,266 corporate executives. Okay, so that's a sample of all the corporate executives. All right, the average number of hours student in your statistic class study per week. Okay, so students, this is tricky. Students in this particular statistic class is actually not the sample, but the population. Think about that. Why is that the population? Well, because I'm trying to gather information about the study, the hours of study per week of my class, of this statistic class. So that means all the student in that class is a population. So your numerical description fitting the average hours of study is 15.8 hours. That got to be the population parameter. Okay, because the students in the class is the population, not the sample. All right. Let me propose another scenario. Okay, a study was conducted at a local college to analyze average GPA of a student who graduated last year. So these are the same choices, okay, as before. Okay, so the one we did not talk about, if you go back and look at the one we did not talk about, okay, they actually mean something else. Like E, for example. This right here, the average cumulative GPA, okay, this is a particular numerical value, okay, and that value representing the average cumulative GPA of student who graduated college last year. Okay, so that's referring to all the students graduated last year, so that must be a parameter because this is describing a population. So that means this one, the average cumulative GPA of student in the study, that's the key, who graduated last year. So the people in your study, okay, is smaller than all the students who graduated from college last year. So this must be a simple statistic. All right. So if you go back here, the population was all the students who graduated last year, right? So that's all the students. Okay, the study is conducted at this local college. Okay. Cumulative periods of data, the sample are a group of students who graduated from college last year. So all the students who graduated college last year is the entire population. So this particular study is conducted at a local college. Okay. All right. Branch of statistics. Okay. There are two major branch. There are two numerical description, parameter and sample statistic. This is about two separate branch of statistic. Okay. Descriptive statistic. Okay. As a science, okay, that gathers, sorts, and summarize, okay, and display data. Everything we can organize, summarize, right, and gather or collecting data. All those are considered as a descriptive statistics. So most of the time, you know, if we conduct a survey of how many male or female in our class, that once we collect that data, we make a table, we make a graph, that will be a descriptive statistic. So descriptive statistic uses numerical summaries, okay, like mean, like average, the word average or mean. We draw tables, so we make graphs from the tables. Those are considered as a descriptive statistic. Inferential statistic as a science, okay, involve using descriptive statistic. Okay, I'm using descriptive statistic to estimate. Okay, this is what we're going to do later on the semester, to estimate the population parameters. Because remember, we're trying to collect data from an entire population, but that's impossible. So we're going to take lots and lots and lots of little samples. So the numerical value from these samples, okay, can be used to estimate what the true population, you know, is, okay, whatever we're trying to study. And that process as a science is called the inferential statistics. So inferential statistics take the results from the sample, okay, whether it's a sample mean, sample standard deviation, okay. We take the result from the sample, numerical value from the sample, and then extend it to the population to measure the reliability of the results. That is called the inferential statistics, okay. So inferential statistics takes the result from the sample, from or samples, okay, and extend it to the population. So we will talk a little bit about inferential statistics toward the end of the semester. Okay, so a lot of topic we're gonna cover at the beginning of this course is about descriptive statistics. And then we will slowly ease into inferential statistics. All right, let's determine whether the statement describe descriptive or inferential statistics. The average price of a car at a new car dealership in town is 29,300. The average price. So you got to think, okay, the average price of the car at the dealership. So am I taking this number and trying to say that all the car, okay, all the average car, okay, is 29,300. No, I'm not saying that. I'm just saying the average price of a car, you know, here's a dealership, here's a new dealership in town. The average car price at that dealership is 29,300. So that would be descriptive statistic. Now, we've seen this problem earlier, okay? A recent poll of 1,266 corporate executives showed that the average price of a corporate executive car is for 45,900. So this same question earlier was asking, okay, was a population parameter or a simple statistic? Okay, and we said that the pole of 1266, okay, that simple, the average from those 1266 is 45,900. So that make that as a simple statistic. That's the average of those guys. So what we're trying to do here, a recent poll shows that the average price of a corporate executive car is 45,900. So that will be considered as a descriptive statistics. Okay, I was gonna say inferential, but I think it's descriptive. Okay, because that number come from, that is an average coming from a poll. Okay, so let's take a look at your homework. Same thing as what you just saw. So for your homework, there are questions that there are answers you need to get from the lecture handouts and from the video. So statistic is a science of, so that right there is from the lecture handout. So this is the science of collecting, organizing, summarizing, and analyzing. So that would be the answer. Okay, analyzing information to draw conclusions. All right, so enter the definition of concept from the lecture handout inside the box below. So on the homework in D2L, you're gonna see there's a box right below it. That's where you type in your answers. When analyzing data population, instead of collecting data from the entire population, we can take many what of a population? We can take many small samples. That will be right here, small samples of a population. What are the two branches statistics? So you can get that from the lecture handouts. Identify the data. Okay, so this is a multiple choice question. All you gotta do is identify the data. So read the scenario and then select which one is the data. All right, identify the population. So this is the same question as earlier. Okay, this is the same scenario as question number 4, but this time you need to identify the population. All right, question 6 is identify, this is a different scenario, identify the sample again. And question 7, I want you to identify the parameter. Okay, I want you to identify the parameter that is being studied in this scenario. All right, question number 8, identify the statistic being studied in this scenario. So make your choices, read through these choices and think carefully, okay? This class is a little bit tricky. Some of the wording can actually dictates, okay? Some of the wording can dictates, the choice can dictates, the way how we think about the meaning of these definitions. So be careful, don't overthink, think carefully, but don't try not to overthink, okay? All right, so if you have any questions, please don't hesitate to let me know. And thank you for watching topic number 1, definition statistics.